by the variations in the saturation described above. The values of the strength and the load are fixed and known. If the known strength always exceeds the known load, then the failure will not occur. However, in most cases there will be some uncertainty about both. The actual strength values of any population of components will vary. So there will be some that are relatively strong, others that are relatively weak, but most will be nearly average strength. Also, the loads applied will be variable. As before, failure will not occur so long as the applied load does not exceed the strength. However, if there is an overlap between the distributions of the load and the strength, and the load values in the high tail of the load distribution is applied to an item in weak tail of the strength distribution, so that this overlap or interference between the distributions is present, then obviously the failure will occur. At number 4, the failures can caused by the wear outs. We will use this term to include any mechanism or process that causes an item that is sufficiently strong at the start of its life to become weaker with the age. Well-known examples of such processes are material fatigue, wear between surfaces in moving contact, corrosion, insulation, deterioration, etc. Similarly, wear out of the mechanism, wear outs of the light bulbs and the fluorescent tubes, etc. Initially, the strength is adequate to withstand the applied loads, but the weakening occurs over the time. The strength decreases. In every case, the average value falls, and a spread of the strength distribution. This is the major reason why it is so difficult to provide accurate predictions of the lives of such items. Number 5, failures can be caused by the time-dependent mechanism. For example, battery run down, creep caused by simultaneous high temperature and the stresses, as in turbine discs and fine solder joints, and progressive drift of the electronic component parameters values are examples of such mechanisms, which are called time-dependent mechanisms. Moreover, the failures can be caused by sneaks. A sneak is a condition in which the system does not work properly, even though every part does. For example, an electronic system might be designed in such a way that under certain conditions, incorrect operations occur. The fatal fire, leave it. Similarly, failure can be caused by the errors. Lots of errors we discussed in our chapter of prevention and detection, I think so, or defect detections. डिफेक्ट के जो चैप्टर था उसमें हमने एरर्स को डिस्कस किया था. किसी भी सॉफ्टवेयर डेवलपमेंट के फेज में एरर हो सकता है, या एरर में वी काज्ड इन टेस्टिंग प्रोसीजर्स और सम मैनेजमेंट प्रोसीजर्स और सम प्रोसेस मॉनिटरिंग एरर्स हो सकते हैं. और थ्रू आउट द प्रोजेक्ट लाइफ साइकिल एरर्स भी अकर हो सकते हैं. फॉर एग्जांपल, डिज़ाइंस ऑफ द सॉफ्टवेयर कोडिंग बाय द फॉल्टी असेंबली और द टेस्ट, और बाय द इनएडिक्वेट इनकरेक्ट मेंटेनेंस, और बाय द इनकरेक्ट यूज ऑफ द प्रोडक्ट, some errors may occur. There are many other potential causes of the failures. For example, gears of some vehicle may be noisy, oil seals can be leaking, or display screens may flicker, and operating instructions might be wrong or ambiguous. Electronic system might suffer from the electromagnetic interface. For example, the mobile communication may cause interruption because of the potential cause of the that may become the potential cause of the failure. तो इनअप्रोप्रिएट ऑपरेटिंग कंडीशंस जो हैं वो भी ऐसी हो सकती हैं कि जिनकी वजह से for example, the temperature is not according to the required temperature of the system in which it was supposed to work or supposed to operate. Consequences of the failure normally हैं financial loss, obviously the cost increase हो जाती है, then breach of the public trust is lost on your product or the service or your company.